Hello everyone. My name is Enrique. I'm a software engineer at Tesco, and today I'm gonna do I will say a little bit unusual talk um, that I hope it makes sense as we go through. And is this one is hardware development with KMP and Compose Multiplatform, but I'm gonna do it through some of the one of my passions, which is guitar pedals. I really love guitar and all the technology around it. And I have to first explain what a guitar pedal is. So guitar pedal is something that takes the input from your guitar and then does some transformation and you ended up outputting that on your guitar amplifiers or a recording desk or something along those lines. To bring that to the programming world so we understand it a little bit better, it's I forgot to mention that you can stack them and you can combine them, but you can think about this like in functional programming when you have things like mapping functions. So a pedal will be just the function that you will have on one of the mappers. So for instance, you could have a compressor that is just one type of effect, or a phaser, overdrives, equalizer. You could do many types, many combination, and delays that are like echo stuff. And one interesting thing about guitar pedals is like we to bring it again to the programming world and to the software development in general. Like we like to brag about our setup. They rate my setup. Look, I have this many screens. Well, guitar players are even worse. Like they love it. They love collecting all sorts of pedals. Now you could do everything digital, but still guitar players like having the original stone boxes and say, oh, I bought that in 1985 or whatever. And it's a whole thing. It's a big thing, guitar pedals. But to understand a little bit further what you do when you combine them, you get different sounds. So you combine a few guitar pedals, and then you get one sound that you can use for one section of a song, and then you combine them in a different way. You combine other ones, and you can have another section. Like say, you have a bridge, and it is all very softy, and then when you go to the chorus, and it's got big distortion and solo with a big delay or echo effect. Or that's what you achieve with those guitar pedals. And there's a little bit of a problem. Sorry, coming back here. If you have that many pedals and you need to go from one sound to another, you need to do a lot of like malabarism and like a juggling. Sorry, touching in one pedal and another. In this case, if you want to go for this, will be a strange example because you will at least share one of the pedals in between the two sounds. But if you want to go from one to another, you need to press 7 pedals like super quick. And if you want to do it in the middle of a song, that's a problem. So one thing that you could do is use what they call switches, guitar pedal switches. So you connect all the guitar pedals, your amp, your guitar into this pink box, and then somehow with some sort of computer you can rearrange that. You do the routing to do that combination that you will otherwise will do pressing all of those pedals. I have to say that there's things that you can buy nowadays that do that kind of thing, but normally you could only connect one or two. And but I thought, let's try to build one ourselves and use technology that I know. And I established. I wanted to define the problem. So the thing we want to do is being able to switch from one combination of pedals to another, from one sound to another, by just doing a single press, and it rearrange everything and instantly. I want some kind of feedback, some visual feedback of what is engaged, so I know what is going to sound. And then I would like some kind of wireless communication for developing an app afterwards, or doing some, yeah, to do an app for this kind of device. But we need to explain a little bit further how it works, the switcher works. Imagine a little bit like the old telephony systems where people were routing telephone lines in switchboards. This is similar to that. So you want to do, you have your pedal connected and you want to go from guitar to on pedal 1 to from pedal 1 to pedal 3 and then to amplifier. The switcher will just do the routing. It will do exactly that same path that you need. And if we go online and say, oh, what kind of hardware does that kind of thing? We need to go like find circuits that do this if we want to build this sort of stuff. And the first thing is like we face this super verbose data sheets that we at the beginning we don't know what they do, and we see things like oh, it communicates by I2C, I don't know what that is. It has 8 inputs and 8 outputs. Cool, yeah, that seems to work for me. And then we buy the chip and it's like, how do we connect this? So the first thing we need to do is create some kind of board, PCB board, and then we need to get a little bit into electronics. That's the thing that is slightly different from our programming world, but you need to get deeper into that electronics world, like in creating the schematics or design the boards, getting some kind of manufacturing system that service that does that manufacture it for you and get shipped to your home. So that's one thing that is slightly different, but you need to do that if you want to develop something like this or any other idea that you have. And the result thing is a board like this one. This is the actual one that is on that device that I'm going to show you in a bit. And then you need to do all the boards. You might want to also do some 3D printing for casing, so it's not all a mess like the first versions of it. It was all messy, all cables around, all very prototypey. Still prototypey, but you can iterate on that. So how do we do this? How do we build this? We are mobile software engineers, not embedded, right? That's the thing. I don't know if you watch this film. It's very 80s film, is the Karate Kid, but the main character is and needs to learn karate in order to face a duel. That's the main plot of the film. But he's given a lot of chores that he doesn't like, and he just wants to learn karate. And his teacher is doesn't teach him any karate at all, and he gets very fed up, and at some point he say, I'm quitting. And then there's the revealing in scene where he say, oh, okay, all the things that you've learned, they are actually useful for actually defending. I'm not saying that that's actually reality, but it's just to say that there's transfer of skills here. Actually, the big run just to say that. But yes, so we have a lot of that knowledge. There's some things that obviously we've seen that all the electronics, you might need to go deeper into that, but we know lots of stuff about UI design, UI programming, software development lifecycle, you name it, architecture, testing, or whatever. You got those skills, and you just need maybe a little bit extra information to go further with what you want to do. So, and which platform can we use? So I don't know if you remember a few years ago, something called Android Things. the initial version of this pedal was done with Android things with a kit that I got in at Laundroid, actually, the cycle closet in a raffle. So that's I got it and I started developing my ideas, and one of them was trying to work with this. But this version is from 2-3 years ago. But you know what happened with Android things? Google just discontinued it, like Google being Google, right? But we have other things. We got the Raspberry Pi. The Raspberry Pi is this super powerful and versatile computer. Like, I think I write that a Swiss Army knife. I think it's a good way of describing it. You can do all sorts of things with that little compact computer. And it's very cheap for entry level projects. I don't know what else to say about the Raspberry Pi. I love it, and we need to run some software on the top of that. So I was looking at this thing called Multiplatform and said, let's see if we can run that on a Raspberry Pi on a thing running in Linux, on a little computer running Linux. So I saw it and I saw that it works for server, Android, iOS, desktop and web. I cannot see any embedded, so I decided to fix it, to take the actual desktop target of KMP and use that to run my own app on the top of that. So a very, very basic version of the architecture for this target is you have your KMP app, it's a JVM desktop, and then you can run and compose on the top of that thanks to Skiko and Skia. Skiko is like the binding library to make Skia work for Compose Multiplatform. Sorry, I mean, it's those two sometimes. The one developed by JetBrains, and Skia is the UI, the graphics library, the open source library which Composer run on the top of that. And you can build some UI, simple UI like this. I say, okay, that's super cool. I can run that. Yeah, that's amazing. Very basic app architecture, like some UI presentation, use cases, and then a switcher state. But that's just UI running on that. We need to actually communicate with the hardware that we mentioned. And then at that point we need to start having a look at the ways the Raspberry Pi have to communicate to those circuits. And guess what? That I2C that we're seeing before is actually natively supported. There's pins dedicated for that under the Raspberry Pi. Super cool. That we can do a connection to the board we developed. That at the same time is connected to all the pedals, all the jack plugs, and we can connect a screen through HDMI. Easy thing, right? How do we write code for this to talk to those pins and write that crazy protocol I2C that we've seen for the first time, right? So this is a very nice project library called Pi4J. So you can easily with a Kotlin DSL or some easy Java, you can talk to these ports, and one of them, the supported one, is I2C. But then later we might be able to use the GPIO, which stands for General Purpose Input and Output, that we could use for other things. And what is actually this I2C? It's just a circuit level protocol. It's something that let us talk to the chips, and the cool thing about it is like it's very efficient in terms of wiring that you have to do. You could, from a main controller, you could connect many targets, many controller devices. The reason why they can share the same pair of cables is because they are using addresses internally. So every target will have a different address. But at the moment we are gonna use only one. But it seems like we could use this protocol in the future to control other things. And we have a look at the data sheet back again, and it seems it tells us how how we need to construct our messages to be able to tell the switcher what we want it to do, like how to rearrange the pedals, the input and the outputs. And there is this device address byte that we need to create. As I said, it's important for the protocol. Then we have another byte that actually is telling you what input without output and whether or not is enabled or disabled. And then there's an extra byte to tell whether or not you load everything at once or you want to keep carrying on adding more commands, more messages before doing the changes. It's a bit, I'm apologize for this because it's very, very low level byte and bits, but we still can do that kind of thing. So a simple example of how it works, this communication to how you build one of these commands is, let's say we want to connect input 2 with output 4. That's X is input, Y is output, I forgot to mention, and we want to set that on. So on will be the more significant bit, and then in binary we just have 2 in binary, and then 4 in binary as well. As simple as that. The only reason why the middle one has an extra bit is just for alignment to make the 8 bits in total. What else? Yeah, and how do we actually write that code? As I mentioned before, Py4j had a DSL, and it's very easy to configure. You just need to start typing Py4j, then you say which is the protocol that you want to use. You name your device. You need the device address that we mentioned before, and the provider. This is something that makes this library super flexible. That you can have different providers, but it's actually how it works below, whether or not it's using file system or specific protocol, but those are like very nitty-gritty details. And then you just write it. You just send the command, and for instance, in this case, I had a command with several bytes, and I was iterating through it and sending it. Not much difficult than that, and it's actually how it sets it up. And this is how we compose the bit. This is basically the same slide that I saw before of how we compose the byte, but with code. No, nothing more different from that. And what happened is we want to send many of those routing, and this is similar in a way to what we do with things like recycle views or in compose nowadays, where you only want to sometimes what you calculate is the difference between the UI that you have and the UI that you want to have. So that's what we do on what we do on this part of what the pedal is doing for this is it has a state of how everything is connected with how the routes are done, the routes between pedals. Then the new state that you want to send is subtracted from that, and then you have a diff state, and that's what you actually send to the chip. So it reduces part of that load. And this is basically, without going too deep into the code, It's basically doing the diff here. No, sorry, the diff is done here, and here you are creating converting the set of pedals to a matrix of ones and zeros, and then doing the diff here. Nothing more complex than that. Now we have an architecture slightly more complex. We have the main architecture that we mentioned before, but now the state is changing. We have like a driver, and the driver is listening to the changes in the state of the switcher. And this was the first version of this of the switcher, and the matrix 8, how I call it. It was running on a Raspberry Pi 3, which is slightly more powerful than what I used later, and it was a very super simple box, and it didn't have any physical toggle switches. But I'm proud also of this first version of it. So the next thing I did was I was thinking, let's now add the buttons that we mentioned at the beginning. Buttons and LEDs, so we can know which set of pedals is, or which preset combination of pedals is engaged every time. So for that, we can use the GPIO, is what I mentioned before. Is just you can configure the pins on the Raspberry Pi bus to be inputs or outputs. So they can either read from a button being pressed, like an on-click listener, or you could set an LED or any other thing if you're thinking about doing some kind of automation project. You could be opening or closing a door, or opening some blinds or something like that. You will use it for that kind of thing. So we've used 2 of the ports, but we have many other ports to use. Like that's super cool that the Raspberry Pi gives you that many to use. And this is an example of how you do the simple circuit of how you do a button reading. There's 2 ways of doing it. There's a pull down resistor and pull up resistor. That only means what you're gonna consider in code, what is a 0 or a 1, depending on how you depending which one you use, is what you consider a 0 or a 1. If it's the 3.3 volts, or if it's ground. So in this case, it was pull down. So you need to specify that in the code, but Pi4J again lets you very quickly with DSL configure configure the GPIO ports to be able to do this. And for the opposite, for as an the GPIO as an output to switch on LEDs is even easier. You just need to connect a resistor to it, and then to ground, and that's basically it. And then the configuration is even easier. You just need to know which state you want it to be, on or off. And now we have a slightly more complex architecture. But everything, things we connect are all independent. It's just they listen to the switcher state, or they set the switcher state. What else? Yes, this was the V2 of the version 2 of the switcher, which is, I have it here if you haven't seen. Oh, I don't know if, yeah, I think it's working, but give it a second. Yeah, on this one I went a little bit more minimalistic. I did a more advanced printing of the case, and added the buttons and the LEDs, and also wanted to try the minimal computer that you could use to run this, and actually with a Raspberry Pi Zero, which is half of the size of the Raspberry Pi, has kind of half of the power, kind of, but it definitely has very little RAM memory. Is more limited, but I wanted to see what was the minimal thing I could run this into. So I managed to run the whole JVM on that. And the only thing is I needed to create my own version of the, not my own version of the operating system, but customize it so it just launched that at the beginning and it doesn't launch anything else. So once that was working, then I started thinking, let's add some communication in case we want to add a companion app. So what options do we have? So we either have TCP IP based options or MQTT if you are into that kind of thing. But we also have Bluetooth, and specifically Bluetooth Low Energy is a nice protocol that lets you create some way of accessing your hardware in a very nice way. It's also very low power consumption, and but the only problem it has is the messaging, the payload that you put in Bluetooth Low Energy has to be very little. That's a constraint it has. I know, but also I thought maybe if I want to take this even further, I want to get to a point where I could connect an app and send like the custom image to have in the screen of the pedals. And for that, I will need something like Wi-Fi and HTTP communication. So going into the Bluetooth Low Energy first. Bluetooth Low Energy, I mean, we had a very nice talk by Tom Colvin like a couple of laundries ago. That was very nice. I don't know if you remember, but he explained very well Bluetooth Low Energy and Bluetooth Classic, and I'm not gonna do any justice, but just imagine this as being a way of defining a way of accessing your hardware, and you can is like endpoints on your HTTP API. If you want to see it that way, to simplify concept a little bit, and you can do reading, writing, and from the client point of view, from whoever is consuming it, you can also subscribe to get notifications. It's like if you subscribe to a flow on coroutines. That's like very broadly explaining BLE. Like I'm not doing justice to it, but I was having a look at how to. You probably seen examples of how to use Bluetooth Low Energy from the client side point of view, but here we are the server. So I was having a look at how you do your own server, and I found this library that has been there for a while, and not many people have worked on it. Most of the projects I've seen, they were done on Python, but so I thought, well, okay, I can use this library, and it was working fine. And I decided to make my own library, which I still working on it. Is in a very basic state. The only difference is it uses Kotlin. Like I took some of the concept of the Py4j library that I mentioned before, and I applied to this library. But basically, it's taking the functionality of this previous library that I showed. And how does the Bluetooth on the Raspberry Pi works? So you have your BLE application on the top, but it has to talk to the core of Bluetooth, and that it does it through DBus, which is some old messaging Linux messaging system. And as I said, most of the examples I've seen are in Python, and you could do it directly, talk to that through Python. But with this library, I could do my Kotlin version of it. But yes, and this is a bit of the example of how would you do it, how you will write it with the library. Let me explain. You need to define a service, which is you need to give it a UID and identifier for your service. So when you create your client application, you can identify that easily without having to search or anything. The characteristics will be the equivalent of endpoints in REST if you want, but you also have to give them UUIDs for the same reason. You can find them, but they are like ports that you can read, write, or get notification from or subscribe to. So that's how you do it. You can define them the capabilities like this, and what you do when you write into it, and also have to add a listener when you get data from it, and do as many characteristics as you want. For instance, I had one to change the different presets, but I had another one to just do the configuration of the different pedals. And in total, the whole application now is way bigger, and now looks a little bit more like this. And it says demo time here, but I did this talk a couple of weeks ago at Joy-Con, and I played the guitar, but that was like an hour and a half just to do a 30 seconds demo. So I thought this time it would be maybe a bit overkill for this, but I recorded a video. I'm sorry because I did it very quickly. I'm butchering the guitar. I'm apologizing beforehand, but it's just for you to see how it works. So you have the sorry. So this is the actual device that we have here. I'll show in a second, and you show what the pedals are connected. Those are every combination of pedals, as I mentioned before, is a preset. So in that case, and you cannot see it there, but they have there's lots of pedals on the other side that are connected to this. And by pressing the different buttons, you change from one to another. It's as simple as that. It doesn't do much more than that. So from there, I went from a clean sound to from more distortion. Like imagine playing a song, like, sorry for the butchering of the guitar. And then I tried a different one with different combination. Yeah, that's awful. Sorry for that. Just to show a little bit the device here. Oops. I don't know if you can see it. I mean, I just saw it in the video, but just if you wanted to see it working. Also, you can control it by BLE if you wanted with a simple app, but that will take a little bit of time to demo. So that was that's the state of the Matrix 8, as I call it. But I want to keep working on it. I want to keep adding stuff. And as I mentioned, I want to add more things like Wi-Fi Direct will allow me to put it on a network and then do getting updates if I wanted to manufacture this and do updates over the air or I don't know, or connect it through a companion app that can send more stuff, not just little messages, Bluetooth messages that change the different pedals. I could actually update images every time. And the cool thing is Bluetooth was a little bit more complicated, but an HTTP server on Kotlin is so easy, right? Nowadays with KTEL you could do something very simple. You could create an endpoint called pedals that you could get the list of pedals on your companion app, or you could set them and you could extend that to have more metadata and do that more complex communication. And what are the things that in the roadmap to keep carrying on with this? Well, I want to do the companion app that I've been mentioning. I would like to add an edit mode. At the moment, you kind of need to compile and upload through SSH every time you want to make a change on the pedal that you connect. So adding an edit mode will be good. Maybe adding a MIDI port, which is this protocol that musicians use to control their instruments, and that could give me some extra functionality, and maybe add things that make use of the computing power of the Raspberry Pi, and also what I would love to do, I mean, just for the sake of it, is getting this to a point where I could send build my stuff and automate how you send update to it, and you could, if you wanted, you could have several devices and send updates to all of them, and all of that automated on a CI system, and that was it. And thank you very much.